Now see here working of a transistor. First I am taking the working of the PNP transistor. Suppose if you have taken like this PNP transistor here where the junctions are shown clearly, here holes are here, electrons are here and holes are here. This is here the P type, N type and this is P type again. This is the emitter, base and collector. Now see here, emitter base junction is always kept in forward bias and this junction has got the low resistance. So emitter base junction is in forward bias. So this P has to be connected positive terminal of the battery and here this. And this battery is named as VEE. So this junction is in forward bias. Because of its forward biasing, it has got the low resistance. Now the collector base junction is in reverse bias. So this is P, so reverse biasing is negative, positive, negative like this here, and this is connected to this. This battery is known as VCC. So this is here in the reverse bias and now this is here base. So now see here, when this voltage is applied here VEE here, because of this VEE, holes are pushed to this side because of this positive terminal and due to the forward biasing. As these holes goes to this side, current flows in the same direction and this current is known as emitter current through the flow of the majority carrier in emitter part. These holes will move toward the base junction. When these holes reaches to the base junction, some electron or some hole gets neutralized by these electrons and the supply of electron or the deficiency of electron is compensated by this side, negative side. So when the electron goes to compensate its position, then the current flows opposite to this, that is called IB base current. But see here, only the very few electron holes are going to neutralize by these electrons present in the base junction. Most of the holes they will passing through this base region and collected by the this is your collector side. And now when these holes are here and these are attracted by this negative here, so again here the holes are getting neutralized by electrons. And now in this case, because of this movement of the holes to this side, current flows here this side, that is called IC. Value of base current is very small, that is measured in actually microamperes. Value of collector current is measured in milliampere and IE also measured in milliampere. You will be getting total current in this circuit IE is equal to IB plus IC. But see here IB is very small value. So basically here the IE and IC is playing role. So this is the working of the PNP transistor. We can see its the working with the circuit diagram, but here see in this side base is common with the both the sides. So we can say this is a common base transistor. So how do we make actually the circuit diagram for this PNP transistor? We take like this symbol and here current is coming like this and this is here this portion. This is in the forward biasing, so it is here done like this. This is called VEE, and here this region is in reverse biasing, so it has to be connected with the negative, and it is like this. This is called VCC. Now this current is IE, this current is here IC. This is going outward, that is here IC, and this is going here IB, and here we can write I is equal to IB plus IC. While making circuit diagram for this, we have to take care of the emitter base junction has to be in forward bias and collector base junction has to be in reverse bias. Now see, let us see the working of the NPN transistor, that is also almost similar to this. So if you have taken NPN transistor in this way, and here we are taking like N, P and N, and this has got the majority carrier electrons and there are the holes and here are again electrons. Now this one is in forward biasing, so has to be connected with the negative and this is with the positive. Collector has to be in reverse bias, so the connected bit to be the positive and negative like this. This VCC and VEE. Now due to the forward biasing of this input emitter base junctions, electron are moving to this side. So the current coming outside, that is IE. When these electron combine with these holes are compensated from here. So the direction of current is that is IB. most of the electrons are passing through the base region and reaching to the collector region, and then due to this positive voltage they are attracted. Because of that, the collector current is flowing this side IC, that is in milliampere. And again the same relation is being justified here, I is equal to IB plus IC. So, this is the action of the transistor. And now we have seen here the emitter base junction is always in forward bias, so it has got the low resistance, and collector base junction is always in reverse bias, so it has got higher resistance. So, actually here transfer of resistance is taking place here. So, we can make the the biasing we can change according to our requirement, and because of this changing the biasing, transistor can work in the different way, like as an amplifier, as an also here the switch, or as an oscillator.